Okay, I'm recording this. So the first thing we're going to do is to draw the 6-inch, 150-pound welding neck flange in 2D. So in order to draw that, we're going to go to our PDF document that has all these sizes on here. So I'm going to scroll down. Now, even though this document has the overall size of a welding neck flange, we're going to use those numbers, but I'm going to go to another document that has more dimensions, and it's this one right here. This is the figure that we're going to use, welding neck flange, 150 pounds. Now, we're going to use the F dimension to draw this. We're going to use the B dimension to draw this. And we're going to use the A dimension, the overall, to draw it, and the G, and the C. I know that's a lot of dimensions, but let me break it down for you. We're only drawing the very outline of it. You can see on the drawing file, we're only drawing the outline. We're not drawing all the detail that we would if we were going to draw this like a machine part and on all the little bitty details. We're not doing that. We're not drawing a section view and adding all those section lines and the holes and the counterboard. We're just making it real simple for this part right now. Later, when you use a more sophisticated program and that valve, when you bring it in, it's going to have more detail. But we don't need to do that for what we're doing right now. We're just getting the gist of this piping. So this is what we're going to do. We need this table, and we need these dimensions. So for instance, I'm going to scroll up here, and here's the pipe size. Here's those dimensions I talked about, the A dimension, the B dimension, the D, and the other one down here, the C dimension, it looks like. Okay, and so I'm going to do that, maybe. So maybe if I do that, we can see both the column heading and the figure. So here we go. Let me try to make this as simple as possible. First, I'm going to draw the flange. Now, the flange is this rectangular piece down here on this part of this area. And so we need to use the A dimension and the B dimension to draw the flange. The A dimension for a 6-inch, 150-pound welding neck flange, these are the two dimensions you need, A and B, 11 inches by 1 inch. I'm going to go to AutoCAD, and I'm just going to pan over a little bit so you can see what I'm doing. Now I'm going to draw a rectangle. You can use a line segment if you want to, it doesn't matter. And then what? The dimensions are 1 inch by 11 inches. So there's the flange of a 6-inch, 150-pound welding neck. Place it on the correct layer. Go ahead and set it. So that's the easy part. And so the next part, let me try something. Really? Okay. See if this will do anything good. I'm not sure. Yeah, that might help. All right, here we go. Split screen. So 11 inches by 1 inch. And now what we need to do is scroll down a little bit and take a look and break this down a little bit. I know that we're going to need this is the flange, and the other part is the weld neck. This outline right here is the welding neck. I think of it as a turtleneck. If I put this thing over my head and it fit, and my head was over here, and my body and neck are on this side, this part would be around my neck, a welding neck, like a turtleneck. And so we need to form this. So this is the way I usually draw it. Here we go. Is it okay that it's sideways like this? Is that okay? You can follow pretty well? So I'm going to use the F dimension first. Line, and the F dimension for this is 3.5 inches. 3.5 inches is the F dimension, which goes from the very bottom of it all the way over this direction, 3.5 inches. Okay, so from here to here, 3.5 inches. Now, the next thing that you need to decide is this. The pipe size is 6 inches, but remember, that's the inside diameter and the nominal pipe size. But the actual size of the pipe, the outer dimension, is really 6 5/8. So really, this distance from, really this dimension from here all the way down to here is 6 5/8. That's the outside diameter of the pipe. Now, when you make your 3D, you're not having to hollow this out, but go ahead and let's make it 6 5/8. Now, here's kind of the center line, and so I want to go half of 6 5/8 to the top and half of 6 5/8 towards the bottom. So I'm going to get my calculator out in my head, and I'm going to do this math. Half of 6, the whole number, is 3. Half of 5/8 is 5/16. So I'm going to go offset 3 and 5/16. If you can't do that in your head, get a calculator, no problem. We'll offset this line up here and down below. And what that just did is it defined the outer diameter of the piece of pipe and the flange, the welding neck right here. Okay? Next, you'll notice that this weld neck flange have these two line segments that are at an angle. And when we look back on our PDF, we can see that here's what that line is representing, and they don't give us the angle of that welding neck. And so what I did to kind of extrapolate was this, and I just made a decision. I said, if I was to start a line segment right here, and I drew this line segment along this angle, it looks like it might line up with where the dimension C is located right here in this area. And so since we're just kind of drawing this 3D schematic, it doesn't have to be identical. I made a decision that, I'm going to locate the C dimension, and then I'm just going to draw a line segment from where G is to where C is. What do you think about that? And that's what I ended up doing. So let's go find what the C dimension is for our 6-inch, 150 pounds. Okay, so here's 6-inch. There's A, B, and C, 8.5 inches. So I came over to my drawing and I offset half of 8.5. Half of 8 is 4. Half of a half is a quarter. And I use my offset tool. And I offset the center line going that direction and the center line going downward. And then as I zoom in closer, I can't just grab this line segment because this side's already connected and just click it over and stretch it. You can draw a line, whatever you want to do. Just connect those 2 points. Erase this line and this line. Trim this line back, erase, and that's how you draw. That's one way to draw a welding neck flange, a raised face weld neck flange, and a fitting for this project. Okay, so that's how I drew that. Now, how do I draw that in 3D? Well, this is how I do it. I'm going to go ahead and spin around to the isometric view, zoom back into that location. We have different tools to do this with and different methods using 3D modeling tools. So here we go. Here's a way to do it. Let me go ahead and switch my workspace over to the 3D modeling. First, I'm going to change my coordinate system to be facing to the left or the right. Then this is one way to do it. I'm going to draw a cylinder. I'm going to snap to the midpoint here. I'm going to define the radius or diameter of the base there, and then I'm going to come over and get the thickness by snapping there. See how fast that was? Because I drew the 2D. That's what I'm talking about, why it's good to draw the two-dimensional shape first. And then the next thing I could do to draw this welding neck flange is just to use that loft tool that we just learned how to use. So I'm going to draw a circle. I'm going to snap on that surface of my flange, pick the midpoint, and snap to where that 4 1/4 inch number is for that side of the welding neck. I'm going to draw another circle on this front side of the weld neck. And then I'm going to use the loft tool, and I'm going to pick those 2 circles. And when I do, it creates a 3D solid of that welding neck. And then I'm going to union those 2 pieces together because it is one fitting and it needs to be one piece. When I move this off, you can see I still have my 2-dimensional shape, but then I have my 3-dimensional shape there and showing and that's what you need to do. It doesn't need to be hollow. It doesn't have to have any other detail on it. It can be just like that. Just keep it simple, just like that. Now that is like a piece of structural steel, meaning that that's just one piece. But you notice I unioned those 2 pieces together. You're not going to union anything else together on this 3D model. You're just going to union your fittings and your pipe. And so that's a way to do that 3D modeling. And then if I wanted to go down here on this object, I could. I usually make all of my fittings first, put them in place, and then go back and make my pipe. But you can make your pipe by doing the same thing. Remember that cylinder? And you can snap here, snap to the diameter of the pipe, and then snap over to this location, and boom, there's a piece of pipe. Don't worry about making it hollow. No big deal. I mean, we could press pull another circle and we can make it hollow, but for what we're doing, this is good enough. All right. And then you just keep going, making these different. There's another weld neck flange. I think it's the same one, so you could copy it. Here is a reducer, again, where you could draw what? A circle, another circle. Do the loft tool, and boom, you're going to have a reducer right there. Okay? You're going to need to draw this T right here. This is a T. And so I already drew it in 2D, and now I just need to make it in 3D. So 2 ways to do this one. I went ahead and drew these circles for the trunk. This is the main trunk of the T. This part over here is called the branch. So think of it like a real tree. You have a trunk, and then you have a branch that comes off of it. I'm going to use either, I could use my cylinder to draw it, or I could use press pull and click the circle and come all the way over to this side. Press pull again. Now when you draw this branch, do this. Come all the way down to the center of this other trunk pipe and make sure that they intersect just like that. Union those 2 pieces together. Union, pick, enter. And now it's all one piece. And the next thing you need to do, spin around, and you need to put in your fillet, right? What size is the fillet, Mr. Turner? Well, I usually make it just the size that it is. What? I usually make it the shortest distance, which is one of these. After I draw the part, I make the radius, and that's how I did my 2D. I made the radius of whatever this was, because it may or may not be even sometimes. So what I did, and what I'm going to do, is I'm going to go to solid, and I'm going to go to fillet edge, and I'm going to choose this edge here. And then when I go to radius, I'm going to go ahead and just, instead of typing it in, I'm just going to pick, this point and this point down there. And that sets my radius for me. And then you can tell that I've already done this and it had the radius set. So then I'm just hit enter, enter, and it makes the radius for you on that T. Over here, repeat. Should be the same radius, so really all you got to do is what? Fillet edge. Pick this, enter, and it didn't work that time. Uh-oh. And so let me try again. Fillet edge, pick. We do the radius again just because. I don't know why it did what it did, but So I have a problem. So then I have to go in and find my problem, wouldn't I? I'd have to go figure out what is going on and why is this not working like the other side. So, I'm kind of glad that happened, because everything I do doesn't work perfect the first time either. It's almost like it's not grabbing. Oh, it's not. Oh, that's weird. Okay, it worked that time. So it was just actually grabbing one side of my arc. It wasn't grabbing the whole thing. So that was kind of strange. I don't know why it did that, but anyway, we got it to work. And so there's our T. Okay. So anyway, there you go. And then there's another tool down here to, you could revolve or loft. But let me go ahead and show you, because I can't help myself. A student showed me this one time, because, again, you could revolve it and make this elbow, or you could do this. Loft, pick both of the cross sections, and it'll make a straight loft, just like that. Hit enter. Then choose path. And then choose this path, one of these arcs over here that you've drawn, because that's your path. And watch what happens. When I pick it, it makes that curved. And so there's your elbow by using the loft tool. This should get you started with drawing these piping drawings in both 2-dimensional and 3-dimensional. If you have any more questions, let me know.